Online mode. Okay, so a very good morning again to everyone and all the dignitaries and faculties and all these participants presented there. So I would like to welcome on in this training program, and thanks to my dear friend and colleague Professor Sadia for giving me this opportunity, to talk about something that's banana farming through the tissue culture mode. Though I'm not a very banana expert, but my expertise is restricted for this tissue culture certification and all that. Anyway, so I would like to just share whatever we have learned in all these techniques, and then I just try to keep it very simple and more in the interactive mode. So just we will not be going into very technical details. So I assume that there are a lot of rural youth and entrepreneurs are there, so they might be interested to know more into the methods and all that. Is that okay, Professor Sadia? Yeah. Okay. So that this banana is really a very popular fruit across the globe, and I have just tried to put here some pictures of some wild species, that how this the current banana has been originated. So there are like two wild species, that this called as Musa acuminata and Galbicinia. They are the two wild progenitors, and then through this we all those domestication and breeding process, we have evolved the current banana that we eat and we see mostly in the market, which is a G9 variety. So as you see that this wild progenitor have a lot of seeds. So this is how through this domestication and this breeding processes we have just developed this variety. So if we talk about the banana area and production, as I mentioned, is that okay? I'm audible. Okay. Because I cannot see my screen here, so I'm just seeing the slides. So if you feel any problem in between, you just stop in between. Okay. Okay. So as I mentioned that it's really, banana is a very popular crop and grown all this tropical and subtropical region across the globe and this Southeast Asia belt. So India, China and Philippines are like the major player in banana production. And even India is like the major producer in the world. So I just got a quick data from this 2021. So it was like the production was 308 lakh metric tons in India, which is a huge in terms of production. And if we talk about the major producing states in India, it's like Maharashtra, Tamil Nadu, and of course Andhra, Karnataka, and now the UP is also becoming a one key player in banana production because this tissue culture propagation, planting materials. So if we see that the per capita availability of banana, so though its data is a bit old, so it was like 14.2 kg in India, the per capita availability in terms of the average global average, which was like 10.7 kg. So we also export banana in other countries, mostly in the Middle East and in European countries also, and in the States also. So if we look to the production statistics which has been published by this National Horticulture Board, so in Andhra topped in 2021-22, and the production was 58.38 lakh metric ton, which is very impressive, and the total share was like around more than 17%. I would say around 18%. Though if you see that Telangana, it's on the 15th rank, but it produced like 1.15 lakh metric ton. So I think that Telangana has a lot of scope to catch up this banana production and then farming. So if you talk about the nutrient quality of banana is really complete, fruit. It has all the vital nutrients that we need. So if you talk about that, it has a good amount of carbohydrate. So here this data has been calculated, considering a medium sized banana approximately of like 100 some grams. So it's like they are good in fibers also. There is a protein, and if the mostly that it's rich in vitamins, that vitamin B and C. So its a daily value is calculated somewhat what an average requirement would be for a daily. So it's like 14% requirement can be fulfilled, of vitamin C can be fulfilled by this that banana. And then they have also good minerals like potassium, magnesium, and they are a good source of antioxidants. So and as mentioned, that they are good source of fibers also. So banana is pretty much a complete fruit, and the good thing is they are low in fat and sodium, so good for that the patients suffering from high hypertension and all that. So this, I have just tabulated some popular varieties just grown in India. I mean, it's a long list, and you see that you can see that this one variety, that dwarf Cavendish, which is commonly called as G9, they are like the most prevalent variety in across all the banana producing states. So this list can be easily, you can get it through that extension bulletins and all that. So I just give a overview. I have just tabulated all these
Sir,
different
excuse sir.
varieties,
Sir,
and then sorry,
sir, your slides are not moving, sir. Kindly check, sir.
it's not moving
Yes, sir. That while species are not moving, sir.
now.
That it's not getting shared, sir. Kindly see, sir.
Can you see now?
No, sir. No. Only first line is showing, sir.
Okay, so first
Yes,
slide
sir.
maybe.
Yes, sir. Now it's showing.
So
Sir, presentation mode पे दिखे सर. Slide show ऊपर से. Yeah, please.
now it's showing.
No, no, sir. No.
I just click this presentation mode.
From the top, sir.
I
Top
think,
left. Slide show. Normal.
yeah,
Next. Slide show.
yeah, this one.
No,
No,
no.
this is,
Fourth one.
yeah,
Fourth one
this
is.
one.
Yes, sir.
Okay, now it's moving.
No, sir. Not moving, sir.
Yeah, I click that also.
Sir, just please increase the size, sir. Size.
Okay, in that mode only.
Yes, sir. Yes, sir. Now it is moving.
Now it's moving.
Yes, sir. Manually it is moving, sir. With the cursor.
Like this.
Yes, sir.
Now it's moving.
No, sir. No.
Oh, I think there is some problem.
Sir.
Now it's here. Can there is any luck?
Yes, sir. Yes, sir. Your screen is showing. Nendra, Kerala.
Yeah, yeah. Popular varieties.
Yes, sir. Yes, sir. Yes, sir.
So shall we go in this mode only?
Yes, sir. This model.
Okay, so maybe we have to go like manually.
Yes, sir.
Wait. I
That
just try
varieties
to.
show different varieties. Yes.
Yeah, yeah. Now it's moving.
Yes, sir.
Okay, so we'll go in this mode only, right?
Yes, sir.
I just try to be, I mean, slides. Okay, so I just mentioned all that, the popular varieties are here of pictures of this, some popular varieties like red banana. It's very, specific in that Kerala and Tamil Nadu region. And then this is, this Cavendish, the G9 variety, which is most popular. So just give a brief idea about their morphology, and I just mentioned some of these, fruits from these varieties. So now it's moving, right, manually?
Yes, sir. Yes,
Okay.
sir.
So I mean, you'll be glad to know that like 7 of the Indian origin varieties have also got a GI tag. There's geographical indication tag. This is something that if any specific produce is correspond to a specific geographical location or origin, then it get a GI tag. So there are 7 banana varieties commonly, producing in for some specific regions in India have got a GI tag. And this GI tag has really a good value and a premium value when it's very specific and you sell in that, you export in international markets, and based on certain characteristics or this taste quality, so it has a premium value. So these 7 varieties, that one is Chenga, is very common in Kerala. Then another one is Kamalpur banana, and then is another one is from Karnataka. So it's a very good thing that we got at least GI tags for these our own varieties. So if anyone is thinking to start some micro corporation or banana production, so they can use these varieties also for some premium prices. So let's come on the topic that we will be discussing more on this. So it's like a large scale production of banana or micro propagation. Usually we call it's a more scientific term. So it's normally we call as a tissue culture, because we just take a small tissue from the plant and we grow them, in some this artificial environment, and then we grow the plants. So banana is usually propagated through conventional means from the that is small suckers or rhizomes. But there are a lot of limitations with the conventional sucker planting techniques. And first and foremost is the presence of this pest and diseases. This is a really very big problem in banana plantation, because virus, it's a long duration crop, so viruses and these pests, they commonly attack this plant, and sometimes they result in complete crop loss. And another issue is the conventional planting, that high cost of suckers. So you need, that these all the suckers for planting material, and you have to transport the sucker to your field. And first of all, you need to get those, good suckers. So they are this is another problem. And another big issue is the low multiplication rates when you do the conventional sucker planting, because it's not all the suckers they will germinate or bear the fruits. So the multiplication rates is also very low, and the bearing capacity is very low. And then there will be a variation in the age and size, because if you get the sucker from different sources, and they are influenced by their own climatic conditions, so there will be a variation in the age and the size of crop when your crop will gradually grow. And as I mentioned, then if the mother plant is diseased and you got the sucker from those plant, then again your planting material will be infected, and it will result in the crop loss. And also the unavailability of uniform sucker. This is also one major problem, because now a lot of farmers are starting this banana farming. So on the onset of monsoon, this is ideal time to start the banana planting. So at that peak time, there is a like peak demand for the suckers. So it's a really challenge to get this uniform quality sucker. So this is one issue that we will face in conventional sucker planting. So just to overcome with these issues, we will switch to this no tissue culture or micropropagation technique. So as I mentioned, the tissue culture is simply propagating a plant from a small piece. You take a small piece, that the prismatic tissue from the growing from the plant, and then you provide the ideal conditions, and then they will grow outside of the plants. So this is called as like tissue culture or micropropagation. The process involves just take a small piece like shoot tip or meristem and place in a medium which is rich in the nutrient, and then you will have clones, thousands and thousands of clones from the same plant, and they would be like genetically identical. So if we talk about the advantages, like they are pest and disease free because you have already chosen your planting material. And you, for sure, I will also talk about some their certification and testing in the later stage. So your mother plant, if your mother plant is free from the disease, and you have taken that sample from that disease free mother plant, and then you do all the process in aseptic conditions, then your the planting material will also be disease free. And then because you are doing this at the same time, all the multiplication, then your crop will have like uniform growth, and then the maturity will be uniform, and you will have sometime that early maturity in comparison to the conventional banana plant. So it's like if you save 1 or 2 months, then your field will be free, and then you can use for growing other crops, and that will give another add revenue to your income. And again, there's around the year planting is possible because you have the control to grow your planting material, so you can have the planting at whatever time you want. And for sure that no staggered harvesting is required in this micropropagated banana. And around 95 and 98% success rates has been observed in banana. That like 98% plants they bear the bunches. And another advantage is if there is a new variety introduced, you can rapidly multiply and put in in the supply chain through this technique. So, if you talk about the requirements, for example, if anyone wants to start their own plant tissue culture or banana plant tissue culture unit, for sure you need a good that infrastructure. It's not very expensive, but you need certain common things that you have to establish in your lab. So, for example, you have a building, and then you have to put like some quarantine area where you have to where you enter first and you clean yourself, and just avoiding all those contamination that you have got on your clothes or in your shoes or something. You don't want to spread this into your culture room, so you need to put a quarantine area where you clean yourself, and then there will be a washing area where you wash your culture media, your equipments, your glasswares and all that. And then there should be a separate media preparation area where you prepare that nutrient media to grow your plants. Then the important aspects is like you need a good culture or grow rooms where you put your plants to grow them, and and where you control all the conditions, so that your planting material grow well. And then of course you need a data collection, so how you need to know that when you start your culture, and then how many passage you have given, and then all that data. So this is like some small equipments that I have just tried to show how it looks like. You need a stirrer just to prepare your media, and that you need a balance because you have to weigh each and every component that you want to use in your media. Then you have to adjust the pH also to your media. Then for that you need a pH meter. Then of course like some refrigerator, because you are keeping your media in a refrigerator just to avoid that contamination, and just stop them to for this wasting. And then you need a water purification because you need a sterile water just to use for your media. And once you have prepared all media, you need to autoclave it just to avoid all those contamination and everything, because this whole process needs a really good aseptic conditions that will increase the chance of success of your micropropagation of this planting material. Because if your culture will be infected, then you have to throw it, and then it will waste all your efforts and resources also. So you need an autoclave, or maybe a big cooker or something can be done to autoclave your media. Then you need this simple laminar flow cabinets. So it has like a negative pressure where you use all those, culturing and everything, all your activities inside this hood, so that you won't contaminate your cultures from that internal, external, microbes and all that. And then you need these culture racks to put your cultures, bottles and all that, and with the sufficient provision of lighting and all that. So these are the basic things that one need when if he is planning to set up a tissue culture, lab or a production facility. So now, if you talk about the methods, so there are like a few important steps in banana tissue culture. Though they are very simple, but I mean, you have to go through all these steps. So the first thing, you have to identify a mother plant from where you will take, the plant, the explant, and then you initiate the culturing using that explant. Then next stage, you multiply that those your cultures, and then you induce the shooting and then rooting, and then we'll have to do some hardening before we release them for like field planting. So I'll just briefly go through different steps. So, right, the first and very important step is selection of your superior mother clone. First of all, you have to identify the which variety you really want to, do for this micropropagation based or your interest or the that market value or something that you are looking for. So it really it's important to selecting this mother clone. So then, if you have to choose a very healthy mother plant that should be free from pests and diseases, and you choose like 4 feet of like the young plant. If you see, there are a lot of pillars coming out from the main branches, so you have to take one the plant that is like 3 or 4 feet of height, and then you dig beneath from the soil like maybe 10 centimeter or something, and you just cut up top upper more, and then because you have to take your tissue that you are going to grow on aseptic condition on a nutrient media from shoot, that's meristematic shoot tips, so that can be find somewhere here. So this is like a steps, how, as I mentioned, that like about 1 to 3 feet tall sucker should be selected, and then you need to cut them till like 10 centimeter or something, before we take them to in our lab, and then we also sterilize these explant, and then we'll start using this material. So, as I mentioned, that disinfection of this propagule is like something that we are going to, take the meristematic tissue from there and start the tissue culture. So we can just simply put this into bleach solutions and for like 30 or 45 minutes, and then we prepare the media that I have just shown here in this the component. So it's simply have to provide some micronutrient and micronutrients, and then vitamins, and then also some hormone. It's a simple, it's a common MS media that we will use as a half strength of this MS media in initiation of our cultures. And of course, you have to control the pH, that should not exceed 5.7. So this is like the initiation of the culture that I have shown. So you take just this, just you get rid of this first layer of sucker. You just have to make a slit, and then you just take out that first layer of your sucker, and then you infect that. After a while, then you again remove the another layer, and we need just the core tissue, and then we just put this tissue in this culture media. You can use test tubes or maybe the magenta blocks or jam bottles. So this is a guy, he is running, commercial tissue culture production facilities. So he's just showing how, there is started this, culture. Then we have to maintain this culture in a culture room, as I mentioned, that air conditioned, that we have to, control the temperature. And initially we provide a good light, like 16-hour light, so the cultures grow well in that. So these are like different protocols that have already been established. It can depend slightly based on the variety we select. So once we have to we start this, we have to optimize the conditions also. Then the next step is just to observe for any contamination. If you see any contamination in your culture, discard them immediately. Otherwise, this will spread in your culture room, and other healthy culture will also be affected with this. Then you have to see if there is a browning or something. Then, I mean, you have to just regularly monitors your culture. That is also a very important step. Then once your cultures are like a 2 centimeter tall or something, then we need to transfer them into another fresh culture media. So we call them as a subculturing. You need to subculture regularly just to avoid the contamination, and then let them grow and multiply also in more numbers. So the media should be the same that I have mentioned, and then you need to do the subculturing about every 3 to 4 weeks until your desired number of shoots are obtained. So this is very important. You have to go like in commercial tissue culture production, people go like 8 or something cycles, but higher cycles are not very recommended, because if you increase your cycles, then there are like chances of some variations that these artificial nutrients may pose on the genetic constituent of the material that you are using. So and then it will create off types or some bad traits also. So usually we should not go like more than 6 7 cycles. That is quite efficient. So here, okay, if I don't know, I mean, there is a because it's overlapped the the slide something. So I just take this out here. So if you see that the subculturing process, so you took a small piece of tissue and you divided into like 4, and then you started your subculturing. So like from one explant, like in one cycle, you put in 4, you cut into small 4 pieces, put into the media, and then it will keep on growing. So after 5th subculture from the one tissue that you started, you'll get like around 4096 plants. So this is how this is that high throughput. And similarly, if you have started 310 or 15 cultures, in that way you can propagate thousands and thousands of micro propagated plant materials. So this is how it's very robust and very high throughput, instead of that conventional planting. So this is how your culture will look like. So if they are like growing more, then you just take out these one individual plants into the different culture medium, and then they will also keep on multiplying. So how you generate like thousands and thousands of plantlets from one tissue that you started initially. Then once your cultures are good enough and they're grown like 3 to 4 expanded leaves stage, then you need to induce the rooting, because rooting is also required for that encourage and all the nutrients management when the plant will go into the field. So this is a medium. You have to use a different medium for rooting. So it's just almost similar, but you just have to check the more hormones, and then you use the same media. So then your rooting will start, and once your plants are rooted, or you see that large roots are coming in your cultures, then you can take to the next step, and you start like the primary hardening. So once the roots are formed, they are hard. That should be hardened in a partially shaded net, because they are still very fragile. So you cannot take them directly into the field. Otherwise, they won't be able to survive. So there are gradual hardening of these tissue culture planting material. So you do the primary hardening. You keep into a glass house, under glass house, or simple poly house, and provide a good humidity around 90% or 80%, and then harden them for like 2 weeks. And then if they are the roots are really good and plants are really hardy, then you have to take them into for the secondary hardening stage. So here are these are like some picture of the primary hardening plant. They are just taken from that culture media, because we use agar also just to as a binding medium. So we have to just remove all that agar and everything, all that the culture media, and then we just put into this net pot, or this culture small trays, net pot trays, and with this some inert or that plant substrate planting like coco peat and vermicompost composition, and then they will do good. And then we'll also take them for the secondary hardening. So we will gradually expose them like more light. So if in the primary hardening like the shed net water was around 75% or something, then you keep like 50%. So just we are making plants to adapt more into the external and real field conditions. So we use some common potting mixture that I have mentioned here, like we use peat soil or this normal farmyard manure, and then mix them and put small these poly bags, and just transplant the primary hardened plants into these small poly bags, and then keep them like for 1 or 2 months into the secondary hardening stage, and then the plant will be good for the planting. So this is something that I have already explained. So these are like the secondary hardened banana plants. You make like small, tunnels, and then this shed net houses and all. So where you harden those plants. These are like the real plants. They are, hardening in the facility. There is a nearby here in Firozabad. There's GRS bio plants. So they have started recently, like in 2 years back, and they are doing pretty good. So these are like the secondary hardened plant, and they are good for dispatch. So this is how you can accommodate a lot of planting material in one this is small carrot. So your transportation cost will be really cheaper in comparison to the traditional the suckers that you have to keep on trolleys and all that. So it said, as I explained the different steps for the micropropagation, and more I will be discussing here that the certification, which is also very very necessary. And now, if you really want to sell your plants in the market with the premium quality, I mean, it's still not mandatory for all the tissue culture facilities, but now my government is mandatory. Like all states have their, this horticulture departments. So they supply the plants to the farmers just to promote this horticulture crops. So for that, they procure the planting material from these tissue culture production facilities, and for them it's now mandatory. If the facility is not really recognized or accredited, or the planting material is not certified, so they won't buy it from those companies. So if anyone wants to start their tissue culture for large scale micro propagation, and for industrial purposes, so one has to think this from the very beginning, that how you gonna certify your plants. So the government of India has already established a system through this Department of Biotechnology, we called as a national certification system for tissue culture raised plants. So they started in 2006, and it's a really very unique and dynamic and comprehensive system because it's keep on changing on every year based on the crop that production facility is raising, and it has a different components. So like the apex body is management NCSTCP management cell. So at now it's NIPGR in Delhi. He is the that institute is the NMC or management cell. Then under this there are referral centers, and then they are accredited test laboratories. So these test laboratories are something like diagnostics laboratories, where if you feel sick, you go, or your doctor and the doctor advise, okay, you go for some test. So this is simply the test for the plants. So you submit your samples to these ATLs, and they will test your plants for different disease and uniformity, and then they will provide you a test report, and based on that report you have to take the next action. If we, what you gonna do with your plants? If they are free from disease, you can easily sell them in the market, and if they are really infected or something, then you have to do some another course of action for to get rid of those plants. So this is the overview of this national management cells. So they recognize the tissue culture production facilities, and they provide the standard operating procedures, that how you start a culture or how you do the culturing, subculturing, everything. They also monitor, that this tissue culture production facilities, that and how they are producing their plants, and then they collect all the different data and everything. They also provide the certification level. So okay, so once your planting material is okay, if it got a positive, it got a test that okay, it's free from all the disease and uniform, then this, they, you will get a label, certification label. You can use those label while you selling your plants. So that would give you a premium to your planting material. So these are like different testing laboratories or referral laboratories across the country. Okay. Hello. 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 Okay. So I mean, like it's a long. I mean, it's a really very. So we will go just through the brief overview. Just I submit. I told you now that you need to raise your plant and submit your samples to the diagnostic laboratories, the test laboratories. They will. These are different steps, so you can just easily, get the information when you are ready for that, and then these are different procedures. I will not go in the details because we are running out of the time already. And these are the fees for that, this virus indexing and the genetic fidelity that they will ask when you have to submit these fees. And then they submit the samples. This is a very nominal fee, and you submit the sample, then they will test it. That's accredited test. They are the certain criteria for the sampling, and then quality of samples, what samples you need to send. You'll get all this information if you visit the NCSTCP website. So I won't go in detail because we don't have the time to go all these details. And then once your samples are tested, then you will get a test report like this, and then you are good to, if your plants are free from disease or everything, you are good to sell in the market. So these are type of some labels that you will get when your plants are tested negative, and you can use these labels for export purposes or for selling to the farmers or to the government supplies. So by August 2020, there were like 22, this 2074 commercial TCPUs were already accredited under this system. And I have just selected, I mean, listed five. They are in Telangana. So they are already, commercially recognized tissue culture production facilities operating under this system. So, yeah. So this is like I did some, based on the farmers' feedback. So this is like cost analysis. So I mean, if you uh, use like 1 acre banana farming, so you'll get around 3.84 or 3.5 somewhere between the net profit, which is really good. And it can go higher also. It will depends on your package of practices, that what practice you'll follow. If you'll do really good farming, then you'll achieve a lot more with this estimated cost. So thank you for your attention. Thank you everyone.
Thank you, sir. Thank you so much. I extend our huge thanks to you, sir. The session was very informative.
Okay, if any question, that I will be happy to answer, or maybe we can take later on through Professor Satya. It's perfectly fine.
Sir, I'm Dr. Suhail, sir. Thank you very much for very impressive and extensive talk on
Yeah. I mean, it's a very long, extensive subject, so probably we need a whole day session for this.
Yeah, thank you very much, sir. Thank you
Yeah.
very much.
Thank you.